the way this works, the way this is successful, the companies that we see doing this well have learned not only to participate, but to do it efficiently and effectively. And that's what we want to talk about next. So I'm going to skip to my next set of charts. And talk a little about what we're seeing companies do to implement this in a new, effective way. Do we know this word, microservice? Who has heard this microservice word? A few people. So microservice is a word that was invented to try to describe what was happening inside the enterprise in implementing service-oriented architecture, SOA. There have been versions of this, have been going on for several years. Amazon talked about this in 2006. ThoughtWorks, the consulting company, used this word, microservice, about 3 years ago to start talking about it. But what's been happening for all this last several years is this ability to figure out how we can implement APIs at a cost-effective and low-risk way. By the way, the API Academy team is releasing a book this year called Microservice Architecture, which we will make sure that you have access to. And it's from all of the API Academy team. So all of my colleagues around the world will be contributing to this book. We're actually in the final chapter this week, and we will return it in for edits, and hopefully it'll be released probably in May. There'll be an early edition of it in 2 weeks, and we'll have to see if we can get some copies that you can share. The way you get copies is you talk to CA. Carlo will make sure that everyone gets one. So first of all, it's important to say, when you read about this microservice, don't be fooled, it's not something new. We've been doing it for decades. Those of us who know IT, those of us who know how to operate a going concern have always been working toward creating things at just the right size, at just the right pace and speed. But there's been an increased focus on it. I'm just going to show this slide. You will get a copy of this slide. I'm not going to go through this list. These have become the topics. Continuous integration and cloud computing and APIs and DevOps and open source. These are the topics that have come together in the last 4 years to sort of make up the language of this idea of microservice. Microservice is essentially the ability for each team in your organization to move at their own pace, to build what they need to build without asking for permission from the rest of the company, without waiting in line, without having a huge number of dependencies. So it's trying to unleash, where we talked about APIs unleashing the value in your company, microservice is an attempt to unleash the talent in your organization. So I don't have to wait in line for a service or to get deployed or all these other things. And when we can build this and we can create this environment, suddenly we can move faster than we did before. It's as if we're taking this big ship that's hard to turn and actually putting it into lots of boats, which are easy to turn. And it really focuses on 3 ideas. The idea of modularity, what is the proper size of a service? The idea of a domain, what is a product or a business unit that makes sense as a service? And finally, the idea of systems. It turns out, and those of us who've been in this business a long time, I can see some people have been in it a few years maybe, we're really dealing with large-scale systems. It isn't just one piece of software, it isn't just one solution, it's large systems. It's our whole IT infrastructure. If I change with this one part, it's going to affect all the others. That's why it's a challenge, because it's a system. So these 3 things, the proper size module, the proper domain or problem, and thinking about how we affect the rest of the organization at each step, that's really what microservice talks about. Brian Arthur is an interesting writer. He talks about this. He actually says that modularity is to the API economy what the division of labor is to manufacturing. We understand in manufacturing how we can start to distribute different pieces of the product to even various parts of the world and bring them together and assemble them. We've learned to create manufacturing systems that make us efficient and effective at this. And I can even relocate parts of manufacturing from one country to the other This is what we need to do with APIs, to make it possible to assemble different parts and bring them together. And as the research has shown to us, this is tended to be very challenging. So the problem that you'll see and that you'll hear that you need to be aware of is you'll see people talking about making services smaller and smaller and smaller. And of course we know when they become so small, they actually become more trouble than they're worth. So anyone that tells you something like every action is a service, or every class, you know, if they're talking about computers, every class in your hierarchy is a service, that's wrong. It's a terrible idea. It's a bit like giving the customer a pile of blocks, or making them assemble your product, right? You don't want to do that. That's crazy. So one of the big challenges is this notion of figuring out the right size. And the way we do that is by thinking about the problem. Remember, I talked in the first section, our job is to solve the customer's problem. What is the customer's problem? Clayton Christensen, who talks about this quite a bit, talks about the notion that customers want to solve a problem, like they want to hang a picture on a wall, right? So maybe they need a drill or something to create a hole to put the nail or something like this. They actually don't care about your drill, they care about the hole. They care about the solution, not the device. So focusing on their solution, focusing on their pain, is how we figure out the problem, the domain. And a great book by Eric Evans called Domain Driven Design, you may hear some of your team talk about this. This book is about 10 years old, focuses on how you can turn that knowledge into something for IT. How we can use that to design our modules and our classes and find the right size. And not do something that's too small. Too small is almost always the bigger danger, not too big. People who like microservices use this word monolith. Has anybody heard this word monolith? Monolith is sort of the word to say your big thing that we don't like. It's like to create a negative term. You want to turn a monolith into microservices. You want to turn something big into lots of small parts. That's good. That's okay in general. But every startup company, every 5-person team in the Silicon Valley or here in São Paulo or any other startup company always builds a monolith first. Because I only need one thing. I don't need to make it complicated to start. So Eric Evans gives us some good ideas about how to make sure we don't make things too small. And this would be one of the big dangers. I'm going to skip this slide. You can see it later. I want to make sure we talk about other things. Basically, it talks about this notion of how you decide what size service. And Eric does a good job of covering that. The last thing I want to mention is this idea of the system. It turns out our entire company is a big system, and systems affect each other, and they have lots of little moving parts. This is a great book by John Gall called System Antics. He is actually trained as a veterinarian. Do we know this term? An animal doctor. But he has this brilliant idea about the way systems behave and work. This is one of his most famous quotes. The idea is that a complex system that works started from a simple one that worked. And you start by creating something simple first. You can't create a complex system to start and then make it work. It won't. So one of the other underpinnings of microservice is to keep things simple, not complicated. And those of us who work in IT and designing software, we sort of understand, there's a sort of a talent to understanding this is getting too complicated. Often we're sort of faced with this notion of, is this the product I want or is this the service I want? And many of us have this thing in our head that says, this sounds like it's making it way too hard. And often products are almost designed to make it too hard because you become dependent on them. Simple products that work always win, always save you money, always save you time. And that's the way we need to think about the way we design our own systems, because it's all about the system. So there's a good book called Building Microservices by Sam Newman, which I would highly recommend for those responsible for actually implementing these. And he has a quote in it that microservices allow organizations to align the architecture of their system with their organization themselves. This is a really important idea. Microservices are an attempt to actually align your IT with your company. It's not the first attempt, it's not the last, but it's a very valid notion. If the microservices are making things more complicated for you, then they're bad for you, right? We want to find the ones, just like we talked earlier, that unlock value in business. Now, this is a gentleman by the name of Mel Conway. Has anybody heard of Mel Conway? I'm just going to talk briefly about Mel Conway. So this is Mel Conway in 1967 when he writes a very interesting paper called How Do Committees Invent? He's writing a paper to try to think about how we bring people together to produce something. And this is the paper from 1967. This is a very complicated sort of premise. I'm going to just kind of give a simple version of this premise. I would encourage you to read this paper. It's rather short. It's about 4,000 words. You could probably read it in 15 or 20 minutes. And it's turned out to be incredibly important to IT today, even though it's 50 years old. Basically, he says communication dictates design. The way we talk to each other, that's the software we will build. If we have lots of memos, lots of meetings, lots of arguments, lots of negotiating, lots of compromise, that's exactly what our software looks like. Lots and lots of stuff that is really just a compromise and nobody gets what they really want. So the way we talk to each other, the way we organize our own committees and everything that we do, that's the software we get. And that's called Conway's Law. Communication dictates design is Conway's Law. I'll talk a little bit more about it here in just a little bit. Okay, so I have one more section. I actually want to talk about Conway because that gets us into culture. That gets us into the way we think about our teams. So I spent the first few minutes talking about the APIs themselves. The API is the distribution. The API can help us create applications and unlock value in our company. And then we talked about this new trend in developing solutions in IT, one that reflects the way small parts work together, simple parts connected to each other in order to unlock the actual talent inside our teams and inside our groups so that people are not hampered or hamstringed. What we find are companies like Netflix and Amazon and Google and all these other companies go to great lengths to actually empower their developers as much as they possibly can to unlock the talent that they have. And what we're finding as we interview them for this book that we've been working on is that we're finding a series of common patterns inside organizations. And that is patterns that create effective teams that actually focus on the humans in the system rather than the code. Many of our customers are a little bit nervous about this topic because most of them are engineers. Most of them are designed to work through software and other things, so the idea of focusing on people can be a little bit intimidating or challenging, or maybe somebody else in human resource should maybe talk to those people. But it turns out the way our teams are created and managed is the way our code looks. So Microsoft did some research in 2009, and they said organizational metrics, the size of your teams and how they interact, will give you an 85% accurate prediction of the number of bugs in code. Not the number of lines of code, not the number of bugs you normally have per line, or any of those things, or even dependencies. Just the way the teams are organized will tell you how many bugs you will have. And that means organizing the teams properly can reduce the bugs. And we already saw this Sam Newman quote as well. So I want to talk a little bit more about Mel a little bit. So we saw him before. He wrote this paper about communication. So what does that really mean? What does Conway's Law mean? Actually, there are a bunch of other great ideas in this paper. Does anybody know this book, Mythical Man Month by Fred Brooks? Yes. So if you haven't read this book, this is definitely a book to have on your shelf. This is an incredibly powerful book about organizing and managing IT. It's a very easy read, very simple read, and very powerful. And Fred Brooks has his own law, that we know this law. Adding manpower late to a software project makes it later. I'm running behind, I'm going to give you 5 more team members. No, please don't. because now we'll be later. And why is that? It's because of communication. It's because every time we talk to someone, there are more people we need to discuss it with. Has anyone heard of Dunbar's number? This is a much less known item. There's a British anthropologist called Robin Dunbar, and he has this notion that there is a sort of a limit to the number of people we can keep track of in our heads. And Dunbar's number is known as 150. It's the sort of the common thing. Dunbar's number is you can have 150 friends, and that's all you can keep track of in your head. And if it turns out I meet a new friend, when I met Carla, I had to kick someone else out of my club because Carla is now one of my friends. In fact, early on, companies like Facebook actually used Dunbar's research, and in the beginning they limited the number of friends you could connect to in Facebook because they thought Dunbar's number would actually be very important. It turns out in virtual friendship that those numbers don't apply the same. But in the beginning we didn't know that. But in real life we do. Do we know this Gore-Tex, the sports product, the Gore-Tex wear? W.L. Gore used to say, I only want 150 people in one building because that's all the people I can remember. If you have more people, create another building next door. And he was even, this was in the 70s, even before Robin Dunbar's information. And lots of other people have talked about the same notion as well. People talk about 150, but I'm much more interested, and our research shows that these three numbers are actually much more important in Dunbar's research. Intimate friends, trusted friends, tribe or team, and then community. It turns out most startups are this size. Why? Because they know everything together. They know how each other are going to work together, and they can move very quickly. When they grow to about this size, there's a little bit of coordination, a little bit, well, we're going to need some extra, just agreement. Let's just talk this out before we get started. You can't just go off on your own. When we get up to 35 to 50, suddenly we have memos and meetings, and people inside the startup say, this used to be a great company, and it's not anymore. Because things change. Each level has its own organizational challenges. So really, Conway's work is about how we can start to think about the culture that we have in our teams and how that team affects code. Team size is important. We need to make the teams as small as necessary. We normally recommend Dunbar level 1 or 2. That's what we see over and over again in companies that are successful. 5 to 15. So whether it's PayPal or Spotify or Netflix or Amazon or Google or Microsoft or all these other companies, they always have that same range of about 5 to 15 on a team. And that's where they get the most speed and the most accuracy in their code production. Beyond that, teams that are 35 to 50 become difficult to manage. Usually you have to break them up. Teams of 150 or more become incredibly hard to manage. And often you're lucky just to get software out the door. So there are some other laws that I want to make sure we talk about, that Conway talks about, because I think people miss some of the real value. And yes, we also know this one, I think, from real life. There's never enough time to do it right, but there's always enough time to do it over. Right? So we tell people, that's okay, don't worry about it, we'll do it in version 2. Right? They say, or we have developer teams tell us, look, do you want it right or do you want it on time? Right? You can't have both, they say. So this is actually a reality. This is true. This is not because things are broken. It's because we always make trade-offs. We do it every day. And in fact, there's a great book on this called The Efficiency Thoroughness Trade-off. Do you want to be efficient and get it done quickly, or do you want to be thorough and solve every possible mistake that you could ever have? Right? And we always make these trade-offs. We make these trade-offs when we're cleaning the house. That's okay, I don't need to do that room today. We make these trade-offs when we're writing the memo. Right? I'm just going to dash off a quick. I'm not going to go into all the detail right now. We make these trade-offs when we buy things at the store, when we drive to work every day, and we make these trade-offs at work all the time. So these trade-offs are about solving real problems in real time, what happens is, what we see over and over again with companies, is that their system grows. Like, we need new features, we need to add more. The rate of change increases. I need the new features faster than I did last year. Now I need them quicker. Now I need them quicker. And then finally, expectations keep rising. Not only do I need the new features faster, but they have to be with less bugs. And this is the pressure, and this is why microservices are becoming so valuable, because what happens when systems get really large is we no longer understand them well. They become complex systems that don't work. The key tool inside these organizations to attack this efficiency problem is continuous delivery. So continuous delivery is releasing code at a faster and faster pace. Not releasing the same amount of code, releasing actually less code. One of the companies that we studied is Etsy. I don't know if you have this company, Etsy. It's a sort of an online store for people who create their own crafts and goods, small market selling. They release to production 10,000 times a year. 10,000 times. 10,000 times, what is that? That is 30 times a day? How do they do this? They do it by releasing very, very small bits. When you think about the math of communication, you think about the math of possibilities. If I release one bug fix into production and it doesn't work, I know exactly what causes the problem. I can remove it. I release an update that has 10 bug fixes in it. There are now close to 100 possible ways that those can combine to cause the problem. I don't know what the real problem is. If I release a bug fix that has 50 bug fixes in it, I have more than 10,000 more than 1,000 possible ways that this could go wrong. So making the releases small and doing them quickly actually simplifies my diagnosis, simplifies my problem, and actually makes it harder to make a mistake. It limits the possibilities. So this is what we see over and over again. So we're doing it over and over and over. That's really the idea of the second law. The second law is that size matters, the problem size, so we make those problems small. Execute many small releases, not just a few large ones. This can be a real challenge to our customers. Many of our customers are built on this every 6 months or every 3 months. Most of the people who are successful at this every 2 weeks or less. As a matter of fact, one of the first things we tell companies when we visit them is just start releasing every 2 weeks, even if you have nothing in the release package, so that your team gets the notion that you're going to release every 2 weeks. That way, if somebody says, oh, I'm sorry, this bug fix won't make it into the release today, there's another release tomorrow. I don't have to worry. It's not a big emotional experience. So this is a tough one. This is a law that says that there's a homomorphism. Does anybody know this term? It's a mathematics term. It's about two things that look identical to each other. There's a homomorphism between your product and your company, is really what this law says. There's a simpler version of this story from Eric Raymond. He basically says if you have 4 groups working on a compiler, you get a 4-pass compiler. 4 teams, 4 units. 3 teams, 3 units. Now this tells you immediately how you can start to think about your teams, how you can think about your software. How many units of software do you want in a release? Do you want 7? How many teams do you think you need? 7 teams. Now you can start to actually change your software by changing your teams. This is a really powerful idea, because the teams need cross-team independence. I need to break up the number of dependencies between my teams. Dependencies are what slow us down. So this third law talks about making teams independent by finding that right size. That goes back to Eric's domain-driven design idea. If you have to hold a release until other team is ready, then you have a problem. Now your company goes only as fast as the slowest team. For many of our customers, the slowest team is actually the ops team releasing. That's the first opportunity you have to reduce your cost and increase your speed without creating risk. This is a great chart from Microsoft, another research project from Microsoft about their dependencies. You know, we have all this software that actually is designed for us to manage dependency. And instead we should just get rid of dependencies. We don't need to manage them, we need to get rid of them. And they talk about what they do. They never take critical dependencies in their teams, or they eliminate them, or they have a backup plan to ship without some other team. They minimize them in general. Design features that minimize dependency will increase your speed immediately. This is another thing that we see over and over again from companies that do well at this. Okay, I have one more that I want to talk about. What we call his fourth law. His fourth law is sort of a combination of things. It basically says large projects and large teams fall apart faster than smaller ones. They go into trouble faster. And it's really for all the things we already know. The first reason is when it's running late, somebody's going to try to add more people to it. Well, that's going to make it later. The second thing is that I can only keep track of so many things in my head at once anyway. So if you start adding more to it, or you start extending the scope, or you start stretching this out over time, it's going to get worse. Our communication is going to get worse, because communication dictates design. Time is against large projects. Time is against large teams. We all have this experience as well. There's actually a company called that puts out a thing called the Standish Group, puts out a thing called the Chaos Report. I don't have a copy of one here, but you can find them online. Chaos Report. And they track large projects, and they track the failures of large corporations and large government projects. And there are lots of them. It's amazing how much we repeat the same mistakes. The larger the teams, the more complex the project, the longer the scope, the more likely it is to fail. If you come to me and say, I can come up with a solution in 2 weeks, and you come to me and say, I can come up with a solution in a month, I will always take yours. 2 weeks. Why? Because I'll know 2 weeks sooner whether or not I'm successful. Simple as that. This is why startup companies have this notion of minimum viable product, right? I don't need to have the Mercedes. I don't need the Audi. I just need a little Vespa. What is the least amount of work I can do to solve this problem right away? This is actually how Amazon creates their online products, their online APIs. They come up with the least that they can do to see if it attracts a crowd. And if it does, then they'll put some money into it. But they want to do it within months or weeks. If anybody comes to you at Amazon, and if you come to the Amazon group and say, well, we want to create a new API, it's going to take us a year. And they say, no, thank you. Go away. A year is too long. One of the advantages of moving quickly is that you learn your mistakes faster than your competitor. And that's actually the most powerful thing, is to be able to learn faster. Because we all make the same mistakes. Your competitors will make the same mistakes. They'll make the same assumptions about the market that you do. But if you make them quicker and you discover the answers quicker, you will win. So, you should always release within 2 weeks or less. If you're missing your windows, if you're missing your release dates, it's because there's too much in the release package. It's much better to release often, early and often. Okay. This is Mel Conway today, by the way. Mel Conway is still alive, working in Boston. He's got lots of wonderful ideas about the way we should think about the way we program. He has done many, many things besides just this one article that he wrote 50 years ago. I will be actually meeting with him in 2 weeks when I'm in New York. And he always reminds me, you know, Michael, I did more than write that one article 50 years ago. He has many, many cool ideas. I think you'll be hearing more from him. But what we learn is that we have to increase communications. We have to actually increase and improve the communications we have within our own organization. If our communication is confused, if it's tortured, if it's complicated, then our software will look like that. So we have to improve that communication, and almost always that's done by making smaller teams and making them more autonomous. We need to support continuous process. Continuous delivery, continuous release. This is one of the most common features that we see in all these companies that are successful in the API economy, is that they release early and often, continuously. Every day you don't release is a day your competitor can get ahead of you. Organize team by products. Rather than create the people who do the data, the people who do the middleware, the people who do the front ends, no. You have a team that has a person that does data, and a person that does middleware, and a person that does front ends, and a person that does testing and release, and a person that does support. That's a team. And then now you have a team, and we own printing in the organization. We own the financial statement. We own the reports for the product group. And now you know exactly who to talk to when something doesn't work. You talk to the team because they own the whole stack. And they can't say something like, well, the problem is the people in middleware haven't set up the ESB yet. You can't say that because you are the people who are setting up the ESB. And they can't say things like, well, the front end people aren't ready yet, the mobile people aren't ready yet. You are the mobile team. So this is an incredibly powerful way to empower a group of people. You own it top to bottom. If it's not released, it's because of something in your team. Change what you need. Tell me what you want. Leadership becomes a coach and a mentor rather than somebody that, whips the team into doing something. Tell me what you need. You have everything you're supposed to have. If you're missing something, let me know. I'll give it to you. And finally, make teams as small as necessary. There's a great story about Jeff Bezos at Amazon. And when he was first creating this process where they would have all these small services working together, his engineers said, well, we're going to have a lot of meetings in order to sort all this out. And he said, no, we're not going to have meetings. I hate meetings. You have meetings because you have too many people to communicate with at one time. There is no team that should be so large that they have to have a meeting. They should be able to just talk to each other every time. And in fact, he created a rule. He said the team could never be so big as that you must be able to feed that team with 2 pizzas. 2 pizza teams. Of course, they were American pizzas, so it's a little different. Right? They're not the little big pizzas. But he said that's the size of teams I want. I want teams that they can sit around the table and talk to each other any time of day. So this idea of Microsoft, this idea of DevOps, this idea of unleashing the value inside your company is really all based on empowering your own employees, empowering your own teams. More than half of the work we're doing today with customers is on this notion of teams and team culture. And as we look at the research about people who understand about APIs and they're having challenges in releasing them and actually creating them, it's almost always because of sociology, not technology. So this is the real secret. And the most disappointing part of this for me is that I don't have a product to sell, right? If I had a piece of software I could give you that would give you the perfect size teams and tell you exactly how they would all be arranged and how that works out, that would be great. But that is not a product. That's us. That's our leadership. That's our ability to pay attention to what's important in our company and what's important to our teams. And what's important to Netflix is not important to you. I have customers who copy what Netflix do. They're in big trouble because they're not Netflix. They're somebody else. They should be doing what's important to them. So this is the big challenge, and I think the people who are successful at this are aimed at this notion of aligning their company culture with what their products are and what their business is really about. And that's what really, I think, is very, very exciting, because that's something everyone can do with whatever technology or whatever business line you're in, whether you're a mature company or a startup company. And I think that's something that's incredibly powerful. So that's what I had to talk about today. I think I'm up to my time, and I would love to answer some questions. If we got some time for questions? Yes.
I have a question.
Yes.
Can you speak more how the APIs associate with security?
Thank you very much. So, security, it turns out, one of the biggest challenges we're seeing in APIs today in security, most of us focus on securing data. And in APIs, data is the least important aspect. What we need to secure is the action, is the activity. Does Mike have the right on his mobile phone in the cafe to read the financials of the company? It turns out I need to know Mike's identity, I need to know Mike's location, and I need to have policies about what we can do inside and outside the company. So this is a new challenge space. Security for data is incredibly important as usual, but now it's important that I have an identity, and it turns out I have many identities, right? I have many identities with even different divisions inside the company, and my location, and my context location. Where am I today? So security is a bit more challenging than we used to have in the past. One of the nice things, what we're seeing people use, whether they're digital natives or other companies, is they're using products that give them context. They actually understand where someone is actually doing some action. This is incredibly important for government data. So in government data, very often we have just sort of CSV files or simple sets of data, and we think that we just need to sort of deliver that data to whoever has access to it. But it turns out some customers of that data need to see just summary information and not detail. Think of healthcare. Health is really important. There are things that doctors should see in my file that I should not see. Right? Doctors want to make sure that I see just the things that are very important. So who I am and where I am is incredibly important. So security is definitely a challenge. It's a feature that we actually see throughout all of the aspects of what we talked about here today. So it's in the design of the software, it's actually in the implementation of the baseline software, as well as the security around it, the gateways, the firewalls, the perimeters, and the proxies. So that's a really good question. It's very, very good. What you're looking for are tools that let you set policy, actual policy, not write code, but actual policy based on those three things: identity, location, and the action you're taking. No, it's good. Anything at all? Maybe there's something I didn't talk about that you would like me to talk about. Yes?
We have been hearing a lot about design of services.
Yes.
Uber or companies like that.
Yes, yes.
Can you tell something about the design of services related to the APIs?
Yes, so this idea of what is a good service design pattern or service design model. We actually did some work with Uber. We interviewed Uber. Uber, when we talked to them 4 or 5 months ago, they told us they have 400 engineers at Uber, 400 people that are responsible for creating software. They have 800 independent microservices. 800 services, 400 engineers. That's like 2 services per person, right? It turns out they don't know what half of those services do. They've completely lost control of what's going on. They've created so many microservices, they have no idea. They're afraid to turn them off because they have no idea what they do. So when they need a solution, they just build a new one and they leave all the old ones in place. So one of the challenges is figuring out sort of that right size pattern and visibility. What we see companies who are good at this do is they actually, Amazon, for example, the first thing you do is you actually write up a case of what the problem is, what the customer is and what their problem is. And if that passes through some review, that becomes the service itself. So that's a way to think about right-sizing services. The other pattern that we're seeing frequently now is less ESB and more message-oriented architecture. So what happens is, in companies that are good at this, they establish some minimum rules. You have to use HTTP, for example. That'd be a rule, right? Then you have to use certain formats, like you have to use, and usually there are these additional structured formats like collection JSON or Siren or HAL or Atom or some of these other things. It's not just XML or JSON. It's actually another version. And all the components have to talk all of the formats. And then you design your resource model based on use cases, and then UIs or front ends can actually use those resources. And so there's this pattern which basically says everyone in the company always uses this protocol and these formats. And then you're free to do your own resource design based on use case. Does that make sense? Is that some of the things you're talking about? Yeah. And we're seeing an increase of what's called hypermedia design. I don't know, has anybody heard this word, hypermedia? So this idea of actually not just having data, but also actions in the response. That's something that Amazon is doing. They actually have several APIs like that. And other large-scale companies in the US are starting to do that as well. Does that help? Is that close? Cool. Yes?
Can you talk a little bit about
Hackathons.
related to the API?
Yes, so the question is, talk a little about hackathons. We actually see a good section of customers, a noticeable section of customers using hackathons as a way to test their products. They do internal hackathons. If they're working on a new API just for their internal use, they'll arrange to have a bunch of developers come in and actually build products with that API. And that gives them great feedback. We've run a handful of these, and you find out very quickly whether or not anyone understands your API. You simply, it's like a huge test. It's like a test bed, right? You give everyone, okay, here's the API, here's a bunch of products we'd like you to build, go ahead. And then you see what they ask you. Can they build it without asking a lot of questions? Is it confusing? Do they create lots of bugs and errors? This teaches you about the design of your API, the actual usability of this API. So it's sort of like that human interface pattern. We've also helped companies start to do this publicly. Some companies who have a public API or a very strong partnership API program will do the same thing with a public. They'll just say, let's go have a big hackathon. We also have some organizations that will arrange a hackathon for you and a bunch of your competitors. So you stand up in front of the room and you say, our API does maps, and it does maps better than Google and everybody else, and we have a contest to build a mapping application, and you'll win an iPad or 10,000 reals or something at the end of the day. And then somebody else will come up and say, we have an API. It's up to others. So hackathons can also give you this opportunity to compare your work to other competitors as well. Do they use your API or do they use somebody else's, and why? So they become really powerful. The way you want to treat hackathons is as a learning experience. And often you learn how badly you've done. And you need to actually accept that. This is especially a challenge inside a company. So if it turns out that your own employees don't understand your API, I've actually seen some managers blame the employee. Oh, you obviously haven't studied, or don't you understand? No, that's the wrong answer. The wrong answer is, well, tell me how I could make this a better API. And that is a very powerful way to do that. It's a good question. It's a very good idea. Yes?
Mike,
Yeah.
in your opinion, where a company should start your API corporate product?
If I understand the question right, you stop me if I'm sort of heading off in the wrong direction. There are a few aspects to this. So one of the ideas is I need to start creating APIs. I don't have a lot of APIs in my company. I need to start exposing services inside my company as APIs. What we see as most successful is creating a very small group of people working on an interface that's not mission critical to the company today, on a very short timeline. So you have lots of things going on inside your company. Maybe there's a thing that does reporting or something, and it turns out I can keep selling my products even if reports are not so good today. So I'll start with that as my API. It's not a good idea the first time to create the most critical part of your company and turn that into an API, because it could sink the whole company. One of the rules we have is no big bets. Don't bet the company on one thing. So start with a small team off to the side and start learning what it takes to create a small team that's effective. Now, once you are starting to design APIs that work, you have a whole series of infrastructure pieces that you need to make sure are in place. So one of these is this notion of an API gateway or a point where I can do security and routing and sometimes some transformation. This is sort of a critical piece. If you don't have this piece, what you're actually asking is that every team reinvent that behavior. So when you have APIs, this idea of a gateway service is really critical. That's not the same as an ESB. Gateways don't have logic in them. They just have connectors and translators and enforcing security. Secondarily, as you start to grow, aside from just a gateway service, you're going to need a discovery service. Most all the companies that are successful at this have some kind of web, some kind of portal, some kind of access central point where they can find what APIs are available. So one of the challenges in a company, especially that's large, is as you begin to create APIs, everybody has to know about them in an easy way. Otherwise, they will invent the same API over and over. They'll invent the same here as they did in Rio, as they do in the US, and so on and so forth. So those are some sort of critical pieces. And then what we see, and I'm sure am I heading in the right general direction of what you were asking? I want to make sure. Yes. Yes. And then what we see companies do is we have this pattern where there's an old phrase, always throw the first one away. Because the first one won't always be right. Be prepared to do it multiple times. So once you iterate several times, that's why you have continuous delivery. Now you have an experienced team, even if they worked on a API that wasn't so critical. Now you can maybe take that experience to another team, and you can sort of level up on the critical aspects of your company, and you slowly, piece by piece, start to refactor your IT infrastructure to this sort of API style. But you don't do it all at once. You don't do it in a big, large scope project. You do it in lots of small ones. Does that help? Yes? Yes, you had a question?
Yeah, Mike. How about the trade-off of you have your own front end versus to make a public API and distribute that for a lot of I don't know, interfaces to consume that? Because I saw a lot of times people talking about, hey, look at WeChat in China. They put all of those services, including financial services, into a single panel chat, WhatsApp line.
Yeah.
And most part of those people say who handles the user interface has the biggest value.
Yes.
And how is this trade-off about thinking about having the user interface or open that for others to have?
This is an excellent topic. We were talking about it at dinner last night. So this notion of once you create APIs, what you're really doing is giving over the power of the customer experience to the front end, and that may not be you, right? So this becomes a real challenge. Banks, we talked about this is basically what banks are challenged with. If banks are suddenly the ones that are just holding and moving money, they lose the customer experience. Apple has the customer experience. So there's definitely a trade-off here. So there's a couple of things going on. One of them is you sort of decide if you want to be the one who's competing at the front end level. And if you are, then you actually design APIs that favor you. A good example of this is actually WeChat. So WeChat does not have an API for the interface, for creating WeChat. But they do have an API for creating plugins for WeChat, right? Because WeChat has decided they want to own that UI experience. Twitter is the opposite. Twitter actually only cares about the information. They don't care about the UI. They have an entirely open API, and they will let lots of customers use their API in lots and lots of different ways, because the value for Twitter is to have more information from more places, as diverse a place as they can. So for Twitter, it's actually strategic for them not to own all the UIs. Every company has to start thinking about where they sit in that strategic play. And you may actually do multiple plays. You actually might have your own interfaces and third-party interfaces, as well as just sort of machine-to-machine technology to find out where your products are, or what your product mix is. But it's really important. You brought up a really good point. You have to be really aware of what you're giving up when you create an API. What am I turning over to somebody else? And it turns out actually it relates to the security question too, because often those of us who own all the aspects to the front end, we make a lot of assumptions about its security. We actually allow the client to make a lot of decisions about what somebody can do and what they can't. And when you're doing third parties building front ends, you cannot allow the clients to decide who has access to what.
Your client.
Right, because it's not your client anymore. So now that's why it's so critical to have these policy systems in gateways and other places, and to design the API so that it's context aware itself, so it's safe for third parties to do that. Salesforce is a great example of this. Salesforce has a real mix of this, right? Salesforce has its own front ends, and there are lots of aspects in their own front end that they don't expose to customers, but there are specific APIs. There are actually specific APIs for SAP that nobody else has, right? They actually package the product specifically for an important customer. So they design their APIs differently for one customer than they do the next. And that's actually one of the great powers of APIs. Since it's all virtual, I don't have to have a new manufacturing line. I just change my APIs, and now I have an API for this customer, and that customer actually becomes so integrated with the way I've offered the API that they won't move to a competitor. So I can actually use APIs as a tactical weapon against competitors by creating such a great API for a customer that it's costly for them to move. Does this help? Is this? Yeah?
Yeah, for sure. And I have one more question.
Yes.
Have you seen any problem related to intellectual property over API information?
Yes. So,
Like,
yeah.
Not the data, the
Yeah.
format and the
Yes.
construction, the name.
That's very good. So the question is, are there intellectual property issues with the design of the API itself? So you may be familiar with a set of court cases in the US over the last several years between Oracle and Google about arguing about the APIs for the Java runtime. So Oracle actually sued Google because Google took the open source version of Java and changed it.
It's the $9 billion.
Right? Yeah. So there was lots of complaint about this, and this is the notion that the APIs could actually be intellectual property, could be copyrighted themselves. Now, because we've got difficulty in the US, our legal system really doesn't really understand IT. Oracle actually won that case, and it's now in its like third round or something like that. So there was some fear in the beginning that web APIs, not just code APIs like the Java runtime, but web APIs might be subject to some of this same challenge. So we definitely have some customers that are worried about that, and our experience and our advice to customers are to make sure that your intellectual property isn't in the URL, isn't in the actual words in the lines and the stuff like that. If your intellectual property is in the URL, you're in deep trouble. But if your intellectual property is in the way it interacts with someone, or the way you process data, or the data you share, then you're in very, very good shape. So far we have not seen anyone start to challenge the actual design of the API URLs as intellectual property. And even if they do, if you make sure your property is, your value is somewhere else, you'll be safe. We haven't seen it yet, but it's certainly something to consider. Yes, yes.
Thank you, Mike.
Yes. Thank you very much. Thank you. We good on time? We good?
Yeah, good.